Hello everyone. Um, my name is Pedro Vidigal. This is Carlos Rolo, and we are here to talk about a multi-cloud strategy with Cassandra using Terraform and Ansible. So first of all, who are we? So Carlos Rolo is one open source consultant in Pythian. He basically deals with everything distributed, certified data stack architect, Cassandra MVP, and basically he's been working with Cassandra databases clusters since 2011, which is when Cassandra began. So yeah, what?
It was really young.
Yeah, so I'm Pedro Vidigal again. I'm the Cassandra team manager at Pythian. I was a former SAP consultant, so I was working in the dark side. And basically, we currently do design and maintain Cassandra solutions for our clients. And so basically talk a little bit about the company. So the Pythian services, what do we provide? We provide managed services for basically most of the databases. So Oracle, MySQL, MongoDB, SQL Server, Cassandra. So you choose, we probably support it. We also provide consulting and strategy and also project implementation. Okay, so we basically currently we manage around 12,000 clients. We have more than 500 consultants. We are a Canadian company, but the company is spread around the world, so we mostly work remotely. And so we do have a lot of experience accumulated over the years and with all the consultants. So let's talk first about the business case of why you would want to go to a multi-cloud solution using Cassandra or anything else for that matter. So first of all, when we're talking about a cloud or multi-cloud, you can choose many cloud providers. Currently, the three superpowers are Amazon, Microsoft, Azure, and GCP. I would say that there are advantages of going one way or the other. So on one hand, Amazon was the first to come into the market, so it has the biggest market share. It's the most established one. It has, in the first quarter of 2018, they had a revenue of $5.4 billion, if I'm not mistaken, which is actually grew more than 50% over last year. And they do have a lot of services available. This is one big plus of AWS. Microsoft Azure also. So one of the big things about Microsoft Azure is if you do have any Microsoft solutions using Office 365 or something like this, you could probably leverage that using Microsoft Azure. And GCP, GCP, for example, they have the artificial intelligence libraries. You can use, for example, TensorFlow and many others like Bigtable or BigQuery. So there's a lot of different reasons why you would choose one over the other. Of course, every single one of them, they had failures. So, and so this is also one thing that you should take into consideration. None of them is 100% bulletproof. And so when you're designing a system, you should take this into account. So what are the benefits of going multi-cloud? So the first major advantage is that you avoid vendor lock-in. You might not want to go full on using the services that the one single vendor provides. But on the other hand, you might want to use a solution that only one of the cloud providers supports, and you would basically want to cherry pick solutions from each of the providers. And if that's the case, going to a multi-cloud solution makes sense. Data sovereignty as well. For example, right now with GDPR, is where your data is located is important, and so this is also important. Contract power, if you have a multi-cloud strategy, and if you're in several clouds, you have more contractual power with the providers, and so you have a bargaining power, and it's more likely that you would be able to lower your costs. Disaster recovery, as I mentioned before, none of them is 100% bulletproof, and so having your data in multiple clouds makes actually a lot of sense when you're talking about DR. And again, as I mentioned, the best capabilities, if you want to cherry pick solutions from each of the clouds, you can. One of the big advantages of Cassandra is that it's fairly easy to do this. You can basically create a cluster and have a data center in each of the clouds, and we have this setup in some clients. We also have setups where we have like one data center in-house and other data centers in the cloud, and it works very, very well. And Cassandra basically deals with the replication of that data automatically. So what are the pain points of multi-cloud? So the APIs different quite substantially. Also the abstractions, the network architectures are different storage architectures. So everything is a little bit different when you're in one cloud, moving from one cloud and the other. So this actually adds quite a bit of complexity to your solution. Again, the supported features differ, as well as the costing models and billing and reporting are different. So you have to understand this aspect of the cloud as well. And again, this just increases the complexity of managing the system. So first of all, whenever you're doing a system like this, and this is very important for Cassandra, Cassandra is distributed, and so you're usually not dealing with one single server. You are dealing with clusters that can go from 3 servers up to hundreds of servers. And if you're doing things by hand, it will probably not scale very well. You would need to hire a lot of DBAs just to handle the cluster, and that's not going to work. So what are the principles? The basic principles of DevOps is culture, automation, measuring, and sharing. I will go through those very quickly. First of all, the culture is very important to whenever you have a team of many teams dealing with your system. It's very important to break the barriers and try to improve the communication between all of them. And again, it's also very important to create an environment where it's easy to share and where sharing knowledge is appreciated, and it's so automation, and this is basically what we will be talking most of the talk. You should automate basically all things. Control versioning, control your versions, continuous integration and deployment, base infrastructure as code, and move without breaking things. This is one thing that basically doing infrastructure as code with Ansible and Terraform really helps, because again, if you're doing configuration changes to 100 nodes manually, it will be highly likely that you would, the first couple of servers you would succeed fairly well, but at some point someone will make a mistake and it will be very hard to track. Measuring, whenever you are automating, you should continuously monitor what you're doing and try to improve. We actually, when we started this path, we knew how much time we were spending per task manually, and so whenever we do an improvement, we know exactly how much time we improved on the task. And again, so basically, if you measure, you are able to make decisions in an objective way. And again, and just to sum up, if you're doing DevOps, it's very important to share your tools, your discoveries, your lessons, your errors, successes, and it's a really good way to document. You don't need to create action plans. The playbooks are basically your action plans and your documentation. So how do we do that? So first of all, we use Ansible to deploy Cassandra and configure Cassandra, and also to manage most of the things Cassandra related. And why do we use this? So Ansible is very easy to learn. It's created in Python, in YAML, and SSH. You don't need basically you don't need to install any agents in the servers. It's agentless. It's very easy to read because it's YAML. It's performant because by default, whenever you run a playbook or a script, it runs in parallel in all servers, and you will see why this is important. And yeah, it's easy to read. It's almost like English. So in Ansible, one thing that you can also do is basically run ad hoc commands. We do this very often in our clients. Again, as I mentioned, when we are dealing with a problem with Cassandra or with some simple task, we almost never do that task in one single node on one single server. You have to do that multiple times, and so simply running these commands using Ansible makes this very, very efficient. And basically, why would you want to run ad hoc commands? Whenever it's something that you don't want to write a playbook for, something that you would only use once, then this is the way to go. Okay, so this is what Ansible playbook looks like. So basically, a playbook is, if you see here, you have the hosts. Basically, this tells you what are the servers you will be running the tasks in. Here, this is only the remote user. Become basically says if you need to elevate yourself to sudo to perform any tasks, it's easy. You just write become yes, and then you use roles. And basically, roles is how you aggregate your tasks in Ansible. So you have here, you can see basically we have this initial role here, the base Cassandra, and if this one is basically the role that is used to install Cassandra, and this one and this one are the ones that are used to configure Cassandra. In this case in Azure, this one for AWS. one thing to notice is that you see in this case you have serial 1 for these two, and there's nothing defined here. Why is this? By default, Ansible runs all the commands in parallel, and most often you do want to have that. And for example, if here we are basically downloading a bunch of packages from the net, and so we want to do this as quickly as possible. So we run this in parallel in all servers. But once we start to configure the cluster, basically in Cassandra, you don't want to, usually when you start to doing things all at once in several nodes, this becomes a mess. Basically, the nodes, there's no masters and slaves in Cassandra. So every node is the same, and so they have to come to agreement of actually what the reality is for them. And so whenever if you start doing everything all at once in the clusters, and we do have this a lot in some clients, we had some problems in some clients that were running Ansible in parallel. So basically it breaks and Cassandra doesn't load, or it creates schema storms. And so, yeah. So that's it. So how do you select the servers you would be running the playbooks? So basically it's in the inventory file. Usually the inventory file is located here, but you can very easily select another inventory file. So usually you have one inventory file here, but if you want, you can use one inside your project. Here you can see we have the IPs we used for Azure, AWS, and GCP. And here, when we were installing the packages, we were basically installing for all of them all at once. To make the Ansible, once you start the number of tasks increases, the playbooks can become fairly complex and very big very quickly. So what's the answer for that in Ansible? So it's roles, and this is how you organize your Ansible project. Basically, you create several roles. So you have the base Cassandra to install, and then here is the role that we used to configure the cluster. So this way, basically, you can see that the playbook is fairly simple. You just know that this is for installing and this is for configuring, but there's not a lot of information here. But once you enter in the roles and in the task, you can see what was happening. So you are basically installing Cassandra. I think there's one missing. Okay, so this is the other way around. So this is installing Cassandra. You can see here that you should use, whenever possible, the modules for Ansible. So here, for example, we are using the apt module. Why is this? Because the Ansible modules provide a lot of verifications, and whenever possible you should use this and avoid basically writing the commands, bash commands, because those are not verified by Ansible. They are not idempotent, and these are. And basically this is just to point out that this is for the configuring Cassandra, and basically here we use in Ansible, you are able to use templates in Jinja, and where you set up flags, variables, and for each the configurations are slightly different per node, and the templates allow you to basically you have one common template, and then you just change the configurations wherever you need. So it's very, very straightforward. And just to finish, we will be releasing the Ansible and Terraform scripts for anyone who wants to see afterwards. So Carlos will now talk about Terraform.
So, hello. So I don't know how many of you know or talked about Terraform. I'm going to be fast about this one. So it's what it is. It's infrastructure as code. So you write what you want. You ask Terraform to plan your infrastructure, and Terraform will display what is actually deploying. And then you ask Terraform to deploy it. And you can also ask Terraform to destroy what you just built. It's really good because this gets automated, but you do a wrong Terraform destroy all your infra. So play with care. It actually can do everything. On all the three clouds have what they called provisioners, which allows you to deploy all their services, or almost all of them, in an automated fashion using Terraform. It's from the same people that wrote Vagrant, Console, Vault, and it's a single Go binary that you push on your machine, and then it does what it needs to do. So this is an example of a Terraform recipe. This is for a resource VM. It does create. It's on a language that is the HashiCorp language. It's a kind of YAML JSON-ish thing. This is a simple example. So we create a resource group. We create a virtual network with the address space, the names. You have to say which stuff binds to where. So create the relationships between the groups. Creating a subnet inside the resource group, inside the virtual network. The planning phase of Terraform does allow you to cut errors when your relationships are not correct. So you try to create a virtual subnet in a virtual network does not belong to the same resource group will throw an error. So it does give you an idea. Also, some editors are ready for the Terraform files already, and they will warn you that this has no dependencies, the dependency here is wrong, so you can get an idea what's going on there. So deploying the Cassandra boxes, you name the Cassandra boxes, where you want them, how you want them, the sizes. This also supports variables. So what kind of hard drives, and this is, for example, where you see the differences between the different providers. So Azure has some kind of managed disk types. AWS is EBS, so you have to define the EBS type, which is a different thing. So these are not exactly or not interoperable as all, as you cannot try to push an Azure thing into an AWS thing. It's the way it is. I think the OS profile doesn't even the OS profiles work the same in the different clouds. So network. This is the L, where L starts when we do this multi-cloud thing. And to be honest, on our example, we dropped the Terraform setting of VPNing between the two clouds, and if you have triple clouds, then you are in for a serious trouble. We are not network experts. We have to rely on some network people on our company to figure out how to, especially when it's the triple cloud thing, how to route traffic between the three clouds in an easy way. Of course, you can always buy virtual commercial appliances, and those will take work for that for a price. but setting up normal VPNs using open source software, it's tricky. You can also use the cloud's own gateways, which still has their own drawbacks, but simplify a lot the networking process. But this is just how to set up a jump box inside, so to isolate the databases from the external. So we set up a virtual box everywhere on our on all our deployments. Yeah, network sometimes leads to that amazing thing. A couple of things, gotchas about Terraform is it's really, really good for testing. So you can just reduce the VM sizes and deploy your things on really small VMs and see how things go. The planning phase gives you an overview of what's going to be deployed. It also allows you to we wanted to do a demo, but the VPN part was really inconsistent, so we didn't want to rely on the demos to fail. So like I said, we set up all the infrastructure, we did a network manually, and then we deploy Ansible. Another thing that is IPs are set when the machines are instantiated, so you don't, for Ansible, you don't know what your IP is going to be like. So one of the solutions found was using DNS. So we set up, the only IPs we get are from the jump boxes, and then internally we use Azure and Amazon DNS to jump through the boxes. So on the Ansible recipe, we put the DNS names that we want, that we know that will exist for our databases. And that's it. This, like you said, we're going to blog about it and push all the codes available. So any questions?
So you create first so you do Terraform apply,
yeah,
and then you run the playbooks independently.
Yes, exactly. We don't chain. You can chain with the external provider on Ansible, on Terraform. You can also do the other way around. If you use you can also deploy everything with Ansible using the EC2 and the Azure things. But I think to keep things isolated, otherwise the complexity grows. Yeah, but we don't. The reason for avoiding the chain is because of the multi-cloud. Yeah, exactly. If it's single cloud, it works just nice. You just pass an environment variable, and it's done. Yeah.
When you use Ansible, how do you manage instances? So if an instance would die and another came back up, would it be auto-provision? Do you have to do that manually? Or if you bring a new server, is that manual or is that automated?
So one of the things so let's imagine a server dies. So one of the things is Terraform sees that the infrastructure changed, and you can tell it to apply, and it will fix what's missing. So if a box actually died in the cloud, the same recipe of Terraform, a single apply will make sure that it picks up the box that is missing with the same settings, and that box will be up. And then you run Ansible to deploy the machine on that machine, to deploy Cassandra on that machine and bootstrap it. But to be honest, we do have different recipes for different situations. It's not always the same. And it's still what happened. It was this, run that role. It was that, run the other role. So we do use Terraform as a baseline to keep your infrastructure the same. And that can be exactly the same Terraform. But Ansible, yeah, it's where things start to get tricky. For example, rolling upgrades, we don't use these recipes. We have another recipe for rolling upgrades. Any other questions? Thanks, everyone.
Thank you.